I'm Professor David Ricketts. I'm a professor of electrical engineering at North Carolina State University. So in this lab, we do tests on radio and wireless designs for low to medium frequencies, so anywhere from a couple kilohertz up to 20 gigahertz. What we have here is a bunch of 3D printed designs. So what we've done is we've 3D printed microwave components, we've coated them with metal, and we've used them to create architectures and designs that we would never be able to. And I think one of the most unique ones I'll share with you right here is this is a genetically designed 3D printed mesh antenna. We have a number of 3D printers. We have several basic 3D printers which just do a thermal polymer, so basically heats it up, melts it, and then puts it in place. And if you'll follow me around, I'll show you the printer that we use to do our microwave components. And this is really interesting. What it does is it uses a projector that is filtered for UV light, and it shines a projected image on a liquid inside of here, and that hardens the liquid, and as it hardens, it moves it slowly up until a complete 3D printed object comes out of the liquid, all defined by the UV light of the projector. And with this, we're able to print down to 50 microns in resolution. So this lab really is catered to high frequency measurements from 20 gigahertz all the way up to 300 gigahertz. So we really are looking at the cutting edge of what's available for wireless communication. And we deal specifically with integrated circuits and high-speed technologies, including optical devices, as well as silicon and other materials. Really, the purpose of the lab is to be able to measure very small quantities at very high speeds. And so we have several pieces of equipment that cost over $1 million, and the purpose of those was to be able to capture the smallest time and the smallest amount of signal possible. So what we have here is one of the premier pieces of equipment in this lab. This allows us to probe down to see the performance of the integrated circuits that we've developed in the lab. We have a microscope here, and the microscope really is just so we can see how to align the connections we have. The wires that we're going to connect to this device are about the size of a human hair, sometimes smaller. And so what we do is we use these different manipulators to get these wires, to put them down and contact directly on an integrated circuit. And then we're able to connect to the equipment around, as you can see right here. We have instruments that can measure the spectrum, so the power over the frequency of the devices. We can also measure the power being dissipated by the device here, and we can also measure some of the thermal properties of the device. And so this is one of the main things that we use in this lab to measure the performance of integrated circuits. So one of the cool things that we have in this lab is we have a laser chamber where we're actually able to put in high-powered lasers, and we use that to alter the electronic states of different materials to build things like radars and imagers. So I'm excited about what we're doing there. And my colleague, Dr. Floyd, also builds very large radar systems. And so we'll see some of the setup and the testing of some of the radar and radio systems that he's building. Here we have a system developed by Dr. Floyd and his students. We have the same probe station with our microscope. And you can see that we've mounted this on a printed circuit board, but we have our equipment surrounding it. We have our network analyzer here, and this is measuring the energy of the RF waves as they go into and out of the part. We're visualizing this on multiple screens. As you can see, we have multiple bias setups, and then we're using additional frequency sources to stimulate the device. So here we've probably got about a dozen different high-speed circuit test devices, all connected together, going into a single integrated circuit, which is probably the size of, probably half the size of your pinky. So I think the most rewarding aspect is understanding something new and having a new idea and then trying it out and seeing that it actually works. So this is a great opportunity to work at the cutting edge of wireless technology with the state-of-the-art equipment in, I think, one of the best university programs in the country.